Okay, let's start numerical 3.8 of section 3.2 rockets. So a rocket with initial mass MO needs to engine to hover stationary and just above the ground. If it can afford to burn no more than a mass, which is the limit of its fuel which can be burned. So for this we have to find that how long can it covers, okay? And there is a hint that write down the condition that the thrust just balance the force of gravity. Here is always the thrust which is from the engine, and using these thrusts we have to balance the force of gravity. After that we have to integrate with respect to time and mass individually, and take this is the exhaust velocity which is to be constant, and after that after finding the equation we have to put some specific values of exhaust velocity, and this is the lambda value which is also the limit of fuel, okay? And for this we have to find that how long could the rocket hover just above the ground. So first you can see the force of gravity acting on the rocket. So obvious there is a formula. This is the mass of the rocket and g, which is the acceleration of the gravity, okay? Now further you can see the thrust generated by the rocket engine, which is this the rate of mass, okay, with exhaust speed. So we have to compare both, okay? So after comparing and put the value of first order derivative which is in time derivative form, you can see after comparing and separating the value, you can see this is the derivative of mass. So you have to separate the value of mass and time. After separating you will get the term, okay? Now for this you have to integrate on it. What's this thing? Okay, but there you can see now you have to integrate, okay? So after integrating you will get the value which we want actually. So there here you can see this is MO, which is the initial mass, and del M, which is the mass of the fuel burned, okay? And these del M which shows that this is must be equal to this lambda MO, which is the limit of its burned fuel, okay? So you can see this is the limit, this is the initial mass from initial to this, which is MO minus del M, and del M is always equals to this gamma M, okay? So you can see now, let's go to its other. So this is after taking the log nature and putting limits, we will get these terms, okay? You can see this is the term. After putting applying integration we will get these term. So now you have to take common MO, okay, and cancel it. By this we will get these term. So now what we have to find there, we have to find t value, okay, time value. So you can see after arranging these equation and get the value of time, okay? So this is the first part A solution. Now second, what we have to find now, there is some specific values, okay, which is already given. Now you have to put these values in these above formula, okay? And after putting values you can see you will get the result of time, and the time is actually 306.12 seconds, okay? So what does it mean? That thus the rocket can hover for approximately 306 seconds. It's almost 5 minutes, okay? And what does it hover mean? It means that when some rocket is instant on some place, stay at some place, okay, and it does not change its position. If it is suspended in air, so it remains there. Okay, so this is all about from my side. Thank you.